All right, we're recording. My name is Jake Thompson, and this is my code for the Hangman project. That is Project4. And so here we go. So this is just a basic template that we've been working on for the past few projects. And here's where we get interesting. So first off, excuse me, I have 6 states. The first one being idle, and then letter select, compare, display, lose, and win. And so here I have key 0 as the button for incrementing and also decrementing if switch 0 is high, but we'll get into that later. So if I increment, then that means I'm selecting a letter. And then when I'm in the letter select state, I mean, if I select a letter, which is pressing key 1, then I would go to compare. And if I reset, then I would go back to idle and restart the game. When I'm in the compare state, if flag goes high, and you'll see what that is in a sec, then go to the display state. If flag R goes high, then go back to letter select. If flag L goes high, then go to lose state. When you're in a display state, if flag R is high, then it goes back to letter select. If flag W is high, then it goes to the win state. When and either lose or win, if reset is high, which is switch 9, then it goes back to idle, which resets the game. And so nothing really interesting here. This is where I update all the hexes. And this is pretty much my main module. But here we get to the state details module. And so here I will go through each of my states. And so here in the idle state, I have the LEDs, only 4 of the LEDs starting from the right as set to high, which should indicate 4 turns. And this is the LEDs is how I'm going to let the user know how many turns they have. And all the hexes are set to 0, as not 0, blank, because of my alphabet, I have 0 set as blank. And hex 0 is going to be an underscore, and this will indicate that it's waiting for a user input. And the last thing that happens in the idle state is that a random number between 0 and 6 is generated, and this will be useful to select one of my words here. I have 6 words. And my words range from 4 to 6 characters, which I should mention that I'm missing one thing in the project, and that's the structural implementation in one of my modules. I just cannot figure out how to do that. And so that's why I got the little 5% extra credit, having a range of characters for each word. So I thought that might balance it out. And yeah, this is pretty easy to implement. And so from the idle state, if the user selects key 0, we go to the letter select state. And in this state, I basically just have a counter that increments each time the key 0 is pressed. And so this will effectively increment or decrement through the alphabet. And also it'll reset once it's cycled completely through alphabet. And how that works here is I just have it starting at 0, and then it increments all the way through 20. And as you can see, my alphabet ranges from 0 to 20 right here, or 1 to 20, sorry. And I will quickly say that my alphabet module is just an altered 7-segment module, just to accommodate for letters and also some numbers. And then we get to the compare state. So the compare state happens when key 1 is pressed. So that means the user has selected a letter from the alphabet. And so here's where the random number selects one of the words. And so once one of the words is selected, let's say it chose nebula. So let's say that the random number was 1. Here we have nebula. And so I have a reg, and L is short for letter. And so I have a reg for 5 letters, and I hard code each letter in. And then I have a very large if statement that just basically says if the user selected letter matches any single letter in the word, then flag goes high, and also check equals 1. And so there's a couple things happening here. So flag being high means it transitions to the display state, and check equals 1 goes to a nested case statement right here for specifically to check if the each of the letters if the letters have completely filled in the word. And so I have 3 checks for words ranging 6 characters, 5 characters, or 4 characters. And so nebula being a 6-character word would flag would make check equal to 1 if any of the letters is equal. So it's continuously checking here if the word is completely filled. And so flag equals 1 goes to the display state. And so in the display state, I have in the compare state, we don't the board really hasn't been communicated to on where to actually display the letter if the letter is correct. And so that's what my display state is for. So here I just have a bunch of if statements saying if the user select is one of these letters, then put it into that specific hex. So let's say that for the word nebula, I selected the letter B, right? And so it would cycle through this. It'd be like, nope, doesn't match L5, meaning in hex 5. Nope, doesn't match hex 4, but it does match hex 3 because B is the 3rd letter in the word. And so what would happen there is BCL3, meaning binary coded letter, would equal user select. And so that means hex 3 would update to that letter that I selected, which would be B. And then when I cycle through the game and I actually want the letters to stay there every time I go back to letter select, I just have each letter, binary coded letter, equal to itself. And this will reset only when the game is completely restarted. That means if switch 9 is high. And so after displaying the letter, flag R goes high. And what flag R does is it just brings it back to letter select. And the whole process just keeps going until either the user runs out of turns right here. Here's where I have each time. So, okay, sorry. Excuse me. Here we have the if statement that checks if the letter equals any letter in the word. But if it doesn't, then incorrect guesses increments. And so each time incorrect guesses increments, and I will say I have a couple counters on here that should increment by 1, but they increment by 2 for some reason, and this is one of them. And so I have a case statement, a nested case statement that checks for each incorrect guess value. So, and then I update the LEDs based on that value. So let's say that I guessed my letter wrong for the first time. I would lose 1 turn, which means LEDs would go from 4 then to 3. And then once LEDs reach 0, flag L goes to 1, which transitions all the way down here to the lose state. And in the lose state, it pretty much just says, you're a loser. You're not very good at this game. And what also happens in there, though, is that the lose count is incremented. And so I have a couple more integers up here, win count and lose count. And this may be a little confusing. It says it starts at 0, but the value 22 I have in my alphabet is 0. So they start at 22. And each time I lose count is incremented. And so that updates hex 0 to display my loss record. And then the same thing happens with my win record every time I check if the whole word is filled out. Then flag W is high. That means go to the win state. Win count is incremented. This is the other counter that increments by 2. And so Here where you would normally see 23, 24, 25, it's just counting by twos, and I just could not figure out. It's probably something super simple, but I just couldn't figure out how to fix that. And um, to make the LEDs scroll or make a funny pattern when I win, um, I just had a scroll counter, a 2-bit scroll counter that would increment, and then I would have a case statement for when it counted through. So it would increment and then it would count through starting at 0 to 3 because it's a 2-bit reg. And I would just have the LEDs alternating as you'll see in my other video just demonstrating the board. And it works pretty perfectly, honestly. Um, Nothing to say. No, one more thing, actually. Here's just where I instantiate everything, and this is how I actually update the values for the hexes. Um, Switch 8, I on the board I have as clear record, and whenever that is switched high, then the win-loss record is set to 0, and you can just clear that anytime you want. And to make sure, but if you don't clear it and you still want to see your win-loss record after playing the game a few times, through each state, I just have lose count is equal to lose count, win count is equal to win count. So that just means each record is stored until it's cleared. And when it's cleared, this is why this is useful, is that when it's cleared, then it's communicating to this and in each state that's, oh, it's just 0, so. But I don't think I'm missing anything. That's about it. Cool. All right, that's my code. All right. How do I stop recording? There we go. Okay, cool. Have a good one. Okay, this is me. And I'm going to be showing you that my board works. Let's see here. All right, so let's play the game. So this is the idle state. This is how many turns I have. I have 4 turns so far. And so here's me incrementing, and if I want to go backwards, I have to press the switch and press this button. I got this idea from Josh. I originally had it to where the 2 buttons would increment and decrement, and then the switch would select it, but that didn't work out. So let's try G. Oh, looks like we have G in the word. Let's see. If I think, okay, I know the word, it's jungle. So let's do the necessary words here. And then let's find an E. And boom. So it looks like we guessed the word, and it says yay, and this is our win count right now. And I'm just gonna keep it incrementing until I get a nice lose and win record so that I could show that it actually increments and stores each record. So now I'm gonna press switch 9 to reset the game and generate a new word. Let's try G again. Okay, G is the first letter, so L, nope. Oh shoot, we lost a turn. Okay, let me just lose this one. Oh, I didn't lose that one, so that means the last one is R. Oh, nope. There's a T. There's a U. Oh, I lost. I ran out of turns, and so that means I lost, and now my lose record is also 1. Let's reset the game here. Let's try to guess again. A. Nope. Okay. C. C. Okay, so that's C. That's a weird placement for C. Let's try G. Uh-oh. I. Oh, I think I know what it is. It's lucid. I think that's one of my words. Yeah, okay. R, U, let's find a D. There we go. So we won again, and look at that. That means we've won twice. So let me also show that my lose counter also counts. I don't think I have F in any of my words, so I'm just going to lose this one. Boom. See, it increments. Let me win one more time, or lose one more time, just to show that it actually works. Yep, there's another loss. Let me go to the win. Let me try to win another one. There's an I in there. Okay. Uh-oh, it might be lucid again. Yeah, it is. Let's reset it. There's an N. Okay. I think the word is nebula. Might be. Yep, it is. Okay, let's. Oop. Go back to an A. And looks like we won. Okay, so now if I press switch 8, it will reset the win counter. Let's reset it. And I want to lose again, so I could also reset the oh my gosh. Reset the my lose record. So that just incremented. Let's reset it. So let me first show that my lose thing reset. Let's lose again. Yep, it's back to 1. Let me try to win again. Okay, I think it's the word is guitar. Actually, I want to show that so one of the words I also have in here is cold, but it looks like it hasn't been selected yet. But so far I've demonstrated a 6 character word and a 5 character word, but I do have a 4 character word in here that I want to try to find. I'll just keep trying this until I get it. Nope. There it is. Oh my gosh, I'm being stupid right now. And let's find an L. And there we go. Looks like we won. So yeah, that demonstrates all my things. Just hangman. Perfect.